This is Chemistry, Unit 14, Acids and Bases. Now we'll practice some calculations using that pH equation. So just as a little reminder, the equation was pH equals a negative log H3O plus. Or you could also write the negative log of H plus. That also works as well, but my particular habit is H3O plus. That's what I'm going to stick with. But both are valid. Okay, let's try an example. It says, what is the pH of a solution with a hydronium ion concentration of 1.0 times 10 to the negative 7th molarity? So first thing you do is write the equation. So you were provided with that H3O plus. That goes right here. But now you need to know how to actually type this into your calculator. So if you have the gray calculators, the TI-36X Pro, you want to hit the negative key, which is at the bottom. And now your log key is under the second key. You have a blue second key. And you want to hit that key twice so that L, O, G, and a parentheses comes up. And inside that parentheses, there should be a flashing cursor. You want to type 1.0. And then you want to hit that EE key, -7, and close the parentheses. And you should be getting 7 as an answer. No significant figures and no units for pH. You're welcome. So the reason you're calculating this pH, like we said, this is easier to deal with, right, with that pH scale than these numbers. All right. Next one. What is the pH of a 1.8 times 10 to the negative 3rd molarity solution of HCl? I just put HCl in red because that's an acid. So let's give this a try. That's hydrochloric acid. So the pH equals negative log H3O plus. So I don't have to give you H3O plus in the question, but I did indicate that this is an acid. That's the negative log of 1.8 times 10 to the negative 3rd molarity. Okay, again now. So maybe you're thinking that every time you type this in, it's just going to be the exponent. Not the case. That only works if you're dealing with 1.0. So let's try this again. You hit negative, which is at the bottom of the calculator, right under the 3. You want to hit the log key twice, so LOG comes up and a parentheses. And then you want to type 1.88, hit the EE key, and then -3, close the parentheses. And now significant figures comes back. If you don't get a whole number, you need to use significant figures. So usually we just keep it to 2. You just try and match whatever was given to you in the problem. So here we'll say it is 2.7 for the pH. Okay. Next example. All right. So now you have what is the pH of a 2.9 times 10 to the negative 5th molar solution of KOH. So KOH is actually a base, which means that you are trying to figure out the pH of a... You're like, okay, so why does that mean anything? Well, it actually affects the answer now, because normally what we've been solving for, right, is pH. So pH equals negative log of H3O plus. This is not the H3O plus because it's a base. This is actually the OH minus. So you can't just type this in here and get the pH. You actually have to obtain the pH. I'm sorry, you have to actually obtain the H3O plus. Well, we can do this, right? You practiced these earlier with the equilibrium equation, so it is possible to get it. It just requires an extra step. So the equation I'm talking about is this one, right? equals the H3O plus times the OH minus. So this, oops, will keep, does not change. We're looking for the H3O plus, so we can solve the pH equation, and you were provided with the OH minus, 2.9 times 10 to the negative fifth. Okay, now to get the H3O plus by itself, you will divide. I don't know what that is. 2.9 times 10 to the negative fifth. All right. Oops, we don't need this. Down here. All right, now to solve this, you want to hit that fraction key on your calculator. See how this is all connected? All right, so on the top, you're going to put 1.0 e to the negative 14th. Oops. 1.0 e to the negative 14. Then bring that cursor down to the bottom, 2.9 e to the negative fifth. And using correct significant figures, you want 3.4 times 10 to the negative 10th molarity. So now you have your H3O plus, and now you can solve the problem. pH equals, so this is why it helps to know if you have an acid or a base in your formula. This is why you learn the nomenclature for them. Negative log of 3.4 times 10 to the negative 10th molarity. And now let's give this a try in your calculator. You hit the negative key. You want to hit that log key twice, so log comes up. You get the parentheses, type 3.4 e to the negative 10, close the parentheses, and let's see what we get. 10, close my parentheses. Sorry, log twice, 3.4 e to the negative 10. And I get 2 decimal places, 9.5. And this should make sense, right? This is a base, so the pH of a base should be in this range, 9.5. So here, this was the pH of an acid, pretty strong one, right? HCl, so 2.7 makes sense. And then here, this 1.0 times 10 to the negative 7th, right? That's right around neutral, and always if you have a 1, the exponent will match. And here we weren't given a chemical, but just anything with this near 7 or on 7, at 7 is neutral. All right, so now what if you have the pH and you want the concentration? So it's going to be the same formula, but how you plug it into the calculator will be different. We're going to use what's called the anti-log. Okay, so let's give this a try. So look at the question here. It says, what is the H3O plus of a solution which has a pH of 4.0? So it's the same equation. Now you have this. How do you get this? That is the question. Okay, so the way to solve this is you need this key on your calculator. So on those gray calculators, you know you have this key, right? This is where you've been hitting the log. So right underneath it, you have this key. So it's called a 10x key. It's right underneath it. So this is the key that you want to hit twice. So if you press that key twice, you get 10 and a flashing exponent. This is exactly what you want. So after you press it twice and you see the 10 with that flashing exponent, in that flashing exponent, you need to type negative. It has to be negative 4.0 and then hit enter, and you will get 0.0001 molarity. Now you can also write 1.0 times 10 to the negative 1, 2, 3, 4 molarity. Oops, it actually helps if I use proper scientific notation, times 10 to the negative fourth molarity. And what do you notice, right? The pH was 4.0, and if you have 1 in front, that exponent should equal the pH. So that's how you know this was done correctly. All right, so now we have a question asking us what is the H3O plus and the OH minus of a solution which has a pH of 7.52. So how are you going to get both of these? Well, you can only start with what you know. So you know you were given a pH, so you know you're going to use this equation. Okay, but now you have the pH, and you are trying to get the H3O plus. So to do this, you want to hit that 10x key twice, right? Hit it twice, and then type in negative 7.52, and it should produce a decimal. I hit it twice, negative 7.5, enter, yes. Now see, you get a lot of zeros, right? So you can either write all of those, but my choice is to put this into scientific notation. So it's 3.2 times 10 to the negative, and I will count 1, 2, 3, 4, 5, 6, 7, 8. And that is my H3O plus. So this part solved. How do you get this part? Well, you know you have another equation to use. It's this one. You have the H3O plus, so you can solve for the OH minus. Okay, if you want the OH minus by itself, you will need to divide. Okay, so you have that fraction key on your calculator, which is right above the 7. You want to press it. In the top part, 1.0, EE to the negative 14. Move the cursor to the bottom, 3.2, EE to the negative 8, and then hit enter. And again, you have a lot of zeros in front. So I choose to put this into scientific notation with correct significant figures. So if you're going to write all those zeros, that 1 should not be there. I'm going to count mine up. 1, 2, 3, 4, 5, 6, 7. Molarity. So you can solve for H3O plus and OH minus from the pH.